Good evening, everyone. This video aims at the difficult questions asked in multiple choice paper of AS level chemistry. I'm going to release some series of videos which help the AS level students, particularly my students, uh, to crack the questions, to break down the multiple choice questions whichever have been felt much difficult in the past 5 years. We are going to try these questions to be simplified and how to answer these kind of questions. That's what the aim of this series of videos. So first I have taken 2024 May June paper 1-1 I have taken. As per the examiner's report, I have seen the following questions are considered to be difficult questions which are not answered by many of the students correctly. So how to make it easier, what is the strategy, or how to simplify these questions and get the right answer. That's what the idea of this video. So let's start with the first question. This first question is about pathway diagrams of chemical reactions. It's from the enthalpy change chapter. So what it talks about, we are talking about an endothermic reaction. First thing is, we are talking about endothermic reaction. When I say endothermic reaction, what should I have is, the product should have more energy than the reactant. So then only the reaction pathway diagram represents endothermic. So let us look at in which cases the product has greater energy than the reactant. It's only A and B, not C and D. So here I'm just going to eliminate the choice of C and D. I'm not going to use. I'm going to consider only A and B. And next, what they are talking about is the activation energy is numerically equal to twice of the enthalpy change of the reaction. So I need to first identify these two terms in the diagrams. So whenever you have a difference between the energies of the reactant and the product, this is the enthalpy change, delta H. So here also I am having delta H. This is delta H. And whenever I consider energy of activation, EA, that is from the reactant to the hump, this is EA. And this is EA. Now let us compare which is double. EA should be double the enthalpy change. Here, this is the height of delta H. This is the height of delta H. And when I consider this is the height, this is the height of EA. Is it twice? This is 1 and this one is covering 3. So they are not 1:2, it's actually 1:3. So that's not a correct choice. Then if I look at here, it gives me an idea of 1:2. So B is the right choice. Only few minutes thinking and few minutes analysis will give me a right answer. I hope successfully we solved the first question. Let's move on to the second question. The second tough question in this paper is considered to be question number 13. What it talks about? It talks about an alcohol Okay. It reacts with ethanoic acid, that's fine. And it's an equilibrium reaction. They have given the concentrations of alcohol and ethanoic acid and water initially, and at equilibrium they have given the concentration of ester formed. What is the value of equilibrium constant? So it's a very easy kind of question. So let me do. I hope in my classes I used to say, let's do this. ROH CH3 COOH, then CH3 COOR and H2O. I'm going to write what is initial. So the initial concentration what we have is alcohol, it is 3.0, then CH3COOH, that is ethanoic acid 2.0, then it's not given as ester is not given, and water is 1.0. Sorry, yeah, 1.0. At equilibrium, what they are saying is the ester concentration is 1.5. As per the balanced equation, 1 mole of alcohol gives 1 mole of ester. So if 1.5 moles of ester is formed, means 1.5 moles of alcohol has been reacted. So that's why I am subtracting that 1.5. The same way, 1 mole of ethanoic acid gives 1 mole of ester. So 1.5 moles of ethanoic acid reacted to give 1.5 moles of ester. And as well, 1 mole of ethanol or 1 mole of, or else for the formation of 1 mole of ester, I usually get 1 mole of water. So already I have 1, and as well 1.5 moles will be formed at the equilibrium, because every mole of ester formed, there will be 1 mole of water formed. So now I am getting the concentrations at the equilibrium. This is 1.5, 3 minus 1.5 is 1.5, this is 0.5, and this is 1.5, this is 2.5. Now Kc is equal to concentration of ester multiplied by concentration of water divided by concentration of alcohol multiplied by concentration of ethanoic acid. So I will get 5. The choice D is the answer for Kc. It has no units because the concentration terms get cancelled. So next question. Question number 22 is again considered as a tough question. When I consider question number 22, compound Q dissolves in water. Fine. So that is a clue given. And compound Q aqueous does not react with dilute sulfuric acid. And as well, compound Q aqueous form precipitate when aqueous silver nitrate added. So when I consider aqueous silver nitrate and precipitate, it may be a halide. So I have been given all the 4 halides. Now I need to worry about which is right. Basically silver nitrate and partially soluble in ammonia. So I can eliminate iodide out of this choice. So B or D may not be the right choice, because only chloride precipitate AgCl dissolves in aqueous ammonia, AgBr dissolves partially in aqueous ammonia, silver iodide it doesn't dissolve in aqueous ammonia. So now either it is a barium bromide or magnesium bromide. Now I need to worry about which one will not react with dilute sulfuric acid. When I consider barium bromide, it is aqueous, plus they are saying Q aqueous, okay, and you are using dilute sulfuric acid, so which will give you barium sulfate solid, and you will get hydrogen bromide aqueous. So you get a precipitate. When I consider magnesium bromide aqueous plus H2SO4 aqueous, it also gives magnesium sulfate aqueous plus 2 moles of HBr aqueous. So what is the difference? How do I say Q doesn't react? How do I say? I just need to write the ionic equation for both the cases. In the first case, you have the solid formed precipitation. So it shows me a clear, visible inference of the reaction. When I consider here, all of the solutions are aqueous and they are colorless. Even though they react, it's going to be colorless. I don't have any visible change in this. So I can say MgBr2, that is magnesium bromide, is the right choice here, not the barium bromide, because barium bromide I can see a visible change of reaction. Moreover, if I write the ionic equation, Ba2 plus SO4 2 minus gives BaSO4. But here in this case, all of them are existing in the aqueous solution. Nothing you will see at the end of the reaction. If you want to write an ionic equation, you may not get an ionic equation with this. So the choice is D. Now I am moving on with the next question, which is 25, question number 25. This is really a tough question, because when it comes to isomerism, mostly the children struggle with the isomerism. So let me check what we can do with it. I may not be able to complete remaining 2 questions that we may see in the next video, because 15 minutes video is much longer for YouTube, that's why. Okay, let's go for it. So here, structural isomerism and stereoisomerism, when I consider, you need to consider structural isomerism and stereoisomerism. What they are talking about is, they are talking about 3-methyl cyclobutane. So I number it 1, 2, this is the 3rd carbon. A mixture containing 3-methyl cyclobutene, which is treated with HBr, and this produces mixture of isomeric bromomethyl cyclobutanes. So how many stereoisomers does 3-methyl cyclobutene have, and how many isomeric bromomethyl cyclobutanes are present in the product mixture? Okay. So when I consider stereoisomer, immediately my mind will say this 3-methyl cyclobutene may show cis-trans isomerism, but it is not going to, because when I write the structure, C double bond C, H, H, then you have C, H, H, C, H, CH3. This is what we are having. So it is not going to show any cis-trans isomerism. But when I consider this carbon is a chiral carbon, so you may have optical isomerism. So it is going to show 2 optical isomerism. One the object and the mirror image. So 2. There are 2 isomers. So I can only look at A and B, not C and D. So these 2 are wrong. Now when I go for after the HBr reaction, when I go for HBr reaction, I may get this product, the first carbon getting a Br, and you have this, and you have CH2 here, and you have CH and CH3. Here I can have 2 isomers, either bromine and methyl group below the plane of the ring, or else above the plane of the ring, nothing more than that, that will be 2. If suppose you are getting the, so totally 2 plus 2, 4, sorry 2, and you are having 2 here, that is, it may be 4 or 6, but we need to find whether it is 4 or 6. If suppose I am having carbon, here I am having the bromine attached. It's a little tough to visualize. Try to visualize. Try to use some molecular models if you have. Otherwise, use some animations that may help you. So here, what I can have is, I can have bromine and methyl group both below the plane of the ring or above the plane of the ring, so 2, and bromine above the plane of the ring, methyl group below the plane of the ring, 1, bromine below the plane of the ring, methyl group above the plane of the ring, 1. So totally 2, 4, 6. So I am getting the choice B is the right one. So this is about the question number 25. I'll try to complete in next few minutes the next two questions. Let me check the next question. The next question, question number 32, is much other difficult one. So compound X is a single pure optical isomer. Compound X is heated with an excess concentrated H2SO4. Only one organic product is formed. What is compound X? That's what the question. So it is X is a pure single optical isomer. It is heated with excess of concentrated sulfuric acid and only one organic product is formed. So concentrated sulfuric acid, which is a dehydrating agent, water has to be removed. So let us consider one by one. If I consider choice A, I have CHOH and I have here CH2 and CH2. So this OH and either this hydrogen or this hydrogen can be released as water. So you may get a double bond here or here. So it's not a single product, it's going to be more than one product. So A is not. Then when I go for B, again I am having CHOH. I have CH2 here. I have CH3 here. Again this OH and the beta hydrogen. So again I may get two different products. The next one, when I consider here, the third one, so choice B is also wrong. Choice C, I have carbon, I have OH, I have CH2 here, and I have CH3 here, then I have. So again this OH, one of this hydrogen or one of this hydrogen, so I may get two different products, not C. Obviously D. So I can check that you have CH2, OH and CH, you have CH2, CH2. I hope this is the chiral carbon, and when you are dehydrating, these only one product will be formed. So that is how it is. And the last question, 37, it's a carboxylic acid with a molecular formula C5. So P reacts with the excess of lithium aluminum hydride to form compound Q. So which pair of molecules could be carboxylic acid P and compound Q? First look at this number of carbon, 5. So check the carbons in the carboxylic acid, 1, 3, 4, 5 carbons, okay. And lithium aluminum hydride, when I go, I'll get the same number of carbons with an alcohol reduction. But here you are having 1 plus 3, 4. So choice 1 is wrong. Then next one, 1, 4, 5. Okay, P can be correct. But on reduction, I am getting an aldehyde. So 1, 3, 4. But lithium aluminum hydride is a strong reducing agent. It results in alcohol. So no. Then finally 3, if I look at, it's the right one. So I'm getting 3. Choice D is the correct choice. So this is how I work with the questions. Only thing I need to remember some of the basic concepts. I will meet you with a other question paper in the next video. Thank you for watching.